Hi, this is Rohan Ali, student of Mechatronics Engineering, Air University Islamabad, registration ID 180867. Today I am going to explain the working and simulation of smart sensors. This project is assigned to us by the instructor and we have to explain the voltage sensor, current sensor, RTC, SD card based on Arduino. Now starting. For this project you need some pre-installed libraries in Proteus files so you can run the project smoothly. Let me show you them. In Tools, Arduino libraries, you have to install the whole library here. I will put their link in the description. You need RTC library and Arduino hex file, and also there is another file to store SD card data, and it is sdcard.mmc. To run this application you need Node++ file. Now coming back to the project, here we are going to drive a motor for which we are going to sense the voltage to the voltage sensor, the current to the current sensor. Here it is a relay which is supported by the LN28303 IC, which is used to drive the high current and high voltage circuit. Now starting from this circuit, here we use optocoupler. Optocoupler prevents the circuit from high voltage or high current. When the switch is closed, the infrared LED put the emitter of optocoupler in active mode and the DC voltage can be drawn from here. No matter how much we put the voltage here, the VCC will always be the constant with the small variations we can make in the circuit. Instead of using wire connection, we use pin connections here. Now, all these circuits are connected to the Arduino with the pin connection. For this circuit, you can check with this cascade menu. Now this pin is connected to this circuit, which highlights in a red color. Now here we have SD card, which stores the data, and RTC real-time controller, which collects the data with the reference to the specific time. Insert the SD card, run the simulation, and a virtual terminal appears. Because we are using a delay time here, the data appearing on a virtual terminal is not a real time based. It is already stored in it. After some time it will show the real time based data because we are using a delay function here. Now the circuits start using the real time data. The relay is closed and the motor is running. Here the voltages appear, and here, since our relay is closed and motor is running, we have some values at the sensors. Starting with the voltage sensor. The voltage drop across this AD pin not showed by this voltmeter. This voltage must not exceed the 5 volts because the voltage more than a 5 volt is dangerous for a microcontroller. To ensure this, we are using a Zener diode which clips the voltage higher than 5 volts. The voltmeter here shows the voltage drop across the motor. If we increase the voltage, the motor is running and drawing more current from the circuit. And if we increase more voltage, it will draw more current and hence our relay is closed. The circuit breaks. In a voltage sensor we use voltage divider rule to calculate the voltage. Now coming to the current sensor. The current sensor is attached in a series with a motor to calculate the current drawn by the motor from the circuit. Here we design a circuit which is used to calculate the current drawn by the motor. The ammeter used here is just to double check whether the current value given by this circuit is accurate or not. The voltmeter used here is just to ensure that the voltage at the pin of Arduino must not exceed the 5 volts as previously explained. This is a setup which is used to check at which frequency our motor is working. Although we are using an encoder motor which displays its value here, but just to ensure our work, we are using a VMS counter timer which shows its value here. You can see the value here at the motor and our monitor is approximately same. And here this is the serial monitor for output. Our virtual terminal is basically our serial monitor which displays the output. Now coming to the values we get at our screen, here you can see the motor current overload is 5.00, battery voltage of motor is 5.00, DC current test which is 2.14, and if we exceed the value from this, the relay actually breaks and the no current drawn from the circuit and the motor stop working. Here we are running at the maximum voltage, the maximum current is drawn and our relay is just about to break. Sorry about the now coming to the source code. Here you can see that we develop Arduino code on which our circuit works. First of all, you have to install some libraries here which I told in the beginning of the video, and here we declare some variables, some constant. In setup we are going to add the serial beginning which is used for the output of the virtual terminal, and now in setup we declare some inputs and outputs, and these functions only run once. Now coming to the loop where the functions are declared and they are running again and again. Now first we declare the function for RTC. Here we use the different logics to get the values of RTC and just to print their values. Next, here we are using a voltage values for the voltage. Now for mapping of voltage we are using some math logics. Mapping the values we use the formula like x2 minus x1 divided by y2 minus 1. Just like that formula we are mapping the voltage between the 2 points here. Similarly for the current and other values. I'm going to explain my semester project, which is a smart and safe kitchen. I used 3 sensors. These are also the smart sensors based on Arduino. Here 3 sensors. The first one is IR flame sensor, which detects the flame through infrared radiations. The gas sensor MQ2, which is used for the smoke detection or a gas leakage, and PIR proximity sensor for the motion detection in the environment. These sensors are not pre-installed in a Proteus file. You have to install them through the internet. I will also share their link in the description. Let me show you where you put their libraries and IDX files and their hex files to run them for any project. In Proteus files, you can find the libraries of sensors. No, here is the library. Let me show you. Here is the library of flame sensor, its IDX file and hex file, along with the gas sensor, and here is the PIR sensor. You can download them. There are number of videos and number of links available on the internet. You can download them easily. I will also share their link and their zip folders. You can download their libraries. Now coming to the main objective of our project, let me show you. It is to design and fabricate the smart system for the kitchen to detect the motion using PIR sensor, gas leakage with the help of gas sensor, and the fire detection with the fire sensor. In our hardware, the main components are Arduino Mega. Arduino Mega is a microcontroller which drives our sensor here. And for gas detection, we are using MQ2. Here we mentioned MQ135. For a flame sensor, we are using IR flame sensor, and for the motion detection, we are using passive infrared radars. The software we are using for the coding is Arduino IDE, which is Arduino Integrated Development Environment. It is developed by the Arduino. And coming back to our simulations, our system works in a way that when there is a human presence or a motion detection inside the kitchen, the PIR sense it through infrared radiations and turn on the LED. Similarly, when there is a presence of smoke or a gas leakage, the MQ2 sensor, which is a gas sensor, give the digital input to the Arduino, and the Arduino initiate the fan and also give the warning alarm along with the flashing LED. Now coming to similarly, when there is a presence of fire inside the room, the IR flame sensor give the digital input to the Arduino, and the Arduino initiate the warning alarms along with the flashing LED. Now let's move to the Arduino code which drives our circuit. So this is the Arduino IDE interface where we write our Arduino code. First of all, we initialize the points where our LEDs are inserted. For example, our first LED for the PIR sensor is inserted at the pin 13. We initialize it here. We also initialize the buzzer here for the warning alarm. And we also initialize the variable for the digital input where our sensor can give the digital input to the Arduino. Now coming to the setup, first we have a PIR sensor. Here we see that the LED shows us the output and the sensor here gives us the input. This pin shows the digital input from the PIR sensor to the Arduino. Similarly, for the MQ2 sensor, which is a gas sensor, we initialize its digital pin and for flashing LED, and this is a serial begin 9600. Similarly for the flame sensor. Now coming to running the loop for the PIR sensor, if the value of PIR sensor is high, if the value of PIR sensor which when we detects the motion, the state of LED must be high and the state of PIR must be high, or else it must be low. Now coming to the gas sensor, if the pin of gas sensor gives the high input, the LED must give the high input also, which means it blinks, and the buzzer also ring. Now here we use a tune and then buzzer, and 450 is its frequency. Delay time we are using the 500 milliseconds, and the no tune, we use the no tune because if we use only the tune function here, the buzzer will only ring once. If we are using a no tune along with the tune function, it means it gives a beeping tune. If we are using only the tune function, it will give a constant single beep. Now coming to the flame sensor, we are using the same logic. If the digital input to the Arduino is high, which means there is a presence of fire here, then the LED also blinks, and we are using also the buzzer function here, which is a beeping tone after the delay of 500 milliseconds. The code is simple, and you can also change the logics according to your project, or you can run the simulation and check out what is going to happen. Before running the simulation, make sure the hex file of every sensor must be placed in their respective files here. Here, the PIR hex file. Now in Arduino, we are going to put the hex file of the code which we have developed in the Arduino IDE to run our project in a respective manner. Let's check the simulation. If we turn the state of a PIR sensor high, the respective LED turns on, and if we turn the input or a state of a gas sensor high, the gas LED turns on, and this flashing LED also turns on along with the beep. So when the state of our IR flame sensor is high, this indicator indicates there is a presence of fire, and similarly there is a flashing LED along with the beeping buzzer. Now let's discuss some of the sealant features and technical specifications of MQ2 sensor. And I'm using this site component 101 to explain you the MQ2 sensor. This is a physical appearance of MQ2 sensor. It has a 4 pins. One is for VCC 5 volts, other is ground, and the next 2 pins are for the digital and analog output. Now discussing its sealant features. Its operating voltage is 5 volt, suitable for our microcontroller. Can be used to measure and detect LPG, alcohol, propane, hydrogen, carbon monoxide, and even methane. Its analog output voltage is 0 to 5 volts. Digital output is also 0 to 5 volts. Preheat duration is 20 seconds. Can be used as a digital or analog sensor. The sensitivity of a digital pin can be varied using a potentiometer. Now it has a potentiometer back here. You can change its sensitivity by varying the value of this potentiometer. Now the MQ2 sensor is a MQ series sensor. These sensors are ranging from MQ2 to MQ309A. The different sensors are used to detect the different gases or different composition of gases. For example, MQ2 is good for methane, butane, LPG smoke, and MQ2 is for alcohol, ethanol smoke. Where these MQ2 sensors are being used, so if you are looking for a sensor to detect or measure gas like LPG, alcohol, these sensors are highly recommended for those purposes. So this is the appearance of a gas sensor when you remove it from the base circuit, and if you remove the upper mesh, it look like this. This element is made up of chromium nickel coil, which is a core material used for the detection of a gas composition. The tabular sensing element is made up of aluminum oxide base ceramic and has a coating of tin oxide. The tin dioxide is almost important material, being sensitive toward the combustible gases. That's why it is used for the detection of gases here. Now how does it works? When the tin dioxide is heated in air at the temperature, oxygen is absorbed on the surface. In clean air, donor electrons in the tin dioxide are attracted toward the oxygen, which is absorbed on the surface of this sensing material. This prevents the electric current flow. In the presence of reducing gases, The surface density of absorbed oxygen decreases as it reacts with the reducing gases. Electrons are released into the tin oxide, allowing current to flow freely through the sensor. Now it is the outer appearance, and it is vary from 0 to 5 volts. Now how you calibrate this sensor? To calibrate the gas sensor, you can hold the gas sensor near the smoke you want to detect and keep turning the potentiometer, as I discussed earlier, at the backside of the sensor until the red LED on the module starts glowing. Turn the screw clockwise to increase the sensitivity. Basically, this potentiometer is just to check or just to increase or decrease the sensitivity of the sensor. So again, discussing some of the salient specifications of the MQ2 sensor, that it has a load resistance of 20k, operating voltage is 5 volt, and heating consumption less than 800 MV, sensitive sensing resist. So since this is my first video and there is always some room for the improvement, I hope in my next video I will improve the flaws which I left. So if you have any query, please let me know in the comment section. Thank you very much.